Good afternoon, everybody, and welcome to the fourth and final instalment of our Supply Chain School Lunch and Learns during the first week of COP26. My name's James Cadman. I work for Action Sustainability, the organisation behind the Supply Chain Sustainability School, and I'm going to take you through the next hour and give you an overview of offsetting and net zero and what they mean as part of your carbon reduction strategy. I'm sharing my slides and we'll share a copy of these afterwards, so do sit back and listen. Some house rules. Just adjust a couple of things on my screen. There you go. Some house rules. Your cameras and mics are off, but please do use the Q&A function within Zoom if you want to pose a question to me. You'll see in the bar, probably at the bottom of your screen, there's two little speech bubbles with the letters Q&A beneath them. If you want to use that to post a question to me, that's great. Just adjusting my screen again. There we go. Please do share your feedback at the end. As always, it's good for us for our own continual professional development and improvement within the school to understand what you like, what you think we could do better, what else we could be doing. So my colleague Sophie will be posting a link in the chat box nearer the end for you to go and fill in an online form on that. So that's really helpful. Like I say, we'll share the slides afterwards. Sophie will post them out to you as a PDF. So do take notes if you want to, or do screenshots, but you will get the actual PDF slides. And we're recording this session as well. So if you want to share the link with any colleagues or for yourself, for that matter, afterwards to look back, then please do use that link that will be posted. Okay. So what we're going to be talking about today, or what I'm going to be talking about today, is very quickly why we're reducing carbon. We all know this. We're in the middle of COP. I'm sure we're all reading the news in our various outlets and social media channels. We know what's going on. A brief bit about the target and the process, and we need that to set the context for net zero. We need to know what that the process has been over the last few years and why we're talking about net zero now, how we reduce carbon, and then importantly what we do with residual carbon, that hard to decarbonize piece, which is where net zero and offsetting come in. So why are we reducing carbon? If you've been on any of my lunch and learns lately or any of my workshops, you'll have seen a myriad of slides with devastating floods and wildfires and other kinds of impacts on the planet. This is another picture, a different picture, says the same story, but it's a different image to look at. This shows the globe in 2019, and what it's showing is temperature anomalies, how different the temperature was compared to a baseline norm. So the stronger the red, the deeper the red color, it means the further away the temperature was from the norm. And you can see around the Arctic in the Northern Hemisphere and also in the Antarctic as well, there's a marked difference from the norm, a lot higher than it should be. And also other patches around the globe as well in those kind of yellow shades that you can see. There's the odd one or two patch where it was lower than the norm. You know, we do get weather variations, of course, but the general trend was to higher temperatures than normal. And this is the key thing about climate change. If you've seen any of my other things, you'll have seen a graph where I talk about the temperature rise being about 1.1 degrees Celsius. That's an average over the whole globe as a rise compared to those pre-industrial levels. What we're seeing in the Northern Hemisphere, in the Arctic areas and the Antarctic areas, is it's far higher than that. It's +4, +5, and as you can see here, +6 and 7 in some cases. There's some parts of the world where the impact from climate change is a lot quicker, a lot more extreme. So we need to be aware of that, as well as the fact that globally, on average, it's gone up by about a degree, just over a degree. So yeah, if you haven't seen any of my previous workshops, then there will be more in the future, so don't worry about that. And there's also links on the Supply Chain School website to the recordings for those previous lunch and learns. So if you weren't able to get into any of those, do look on the school website. And I'm sure Sophie might be able to drop a few links into the chat box for those previous ones where you can go and get that recording if they're available. Okay, so what is the target response and our progress? So let's take a step back here. 15 years ago, Lord Stern, very eminent economist, looked at the cost of climate change. He and his team did a great report, unsurprisingly called the Stern Review, that came out with some very important figures that essentially said, look, it's going to be cheaper for us as a planet to do something now rather than waiting until the future when we're going to have to pay more. And he couched that as an economist would do in pounds, in GDP figures. And saying, look, if we take action now, it's going to cost some money, but yes, it's going to cost us a lot more if we don't take any action. And that was one of the key sources that led into what became the UK's Climate Change Act, which is driving towards lower and lower emissions. So the UK's Climate Change Act came out in 2008. World-leading legislation, probably the first developed nation to have such legislation. There were others as well, less developed nations, lower-lying Pacific islands. But initially, that was an 80% reduction in our emissions by 2050 against the 1990 baseline. So this is not net zero yet. This is just about an absolute reduction of 80% of our emissions, but still allowing ourselves to emit a certain amount. So that came out in 2008, and it was predicated on this kind of working our way down. And this is a graph from the Committee for Climate Change that came out nearer that time. And again, you might recognize this graph. It's a slightly older version of that, and I put it here deliberately to show that this wasn't talking about net zero at that point. You can still see there's that kind of that green bar on the right hand side at 2050 saying we are still allowing ourselves some emissions, including international aviation, which is what the IAS stands for. And you see we can tracking down. The solid black line is what we've done already since 1990, and then the dotted line was our trajectory going on from then. So yeah, we're still allowing ourselves some emissions from that. But around 2015, 2016, the Paris Climate Change Agreement was basically saying, look, we need to push to net zero. We need to bring our emissions down to a net zero. So not 80% reduction, but 100% reduction. And driving forwards to reducing and decarbonising our emissions as much as possible. And this was in line with a 2-degree warming scenario, and that's even been pushed further to 1.5-degree warming scenario. So really, really important. And part of the mechanism in that is something, a phrase you might have heard on the news over the last few days, is NDCs. It's another acronym we have to learn, nationally determined contributions. So this is what each country is going to do about its own emissions to reduce them. The UK's NDC is a 68% reduction by the year 2030 compared to 1990. So that's what we need to contribute, and every nation has come up with its own NDC to put into the mix. And those are being discussed and ideally strengthened in Glasgow while we speak. The Intergovernmental Panel on Climate Change came out with a report in 2018 that kind of took the science that went into the Paris Climate Change Agreement a couple of years prior to that and said, actually 2 degrees isn't enough. It's going to be really impactful. The changes to the climate, the changes to the weather patterns are going to be really impactful. We're going to have to go better, go faster, do more, because otherwise we'll have more flooding, more extreme weather events, more coral reef bleaching, more impacts on biodiversity, more pollution events, and so on. So if we can limit that warming below 2 degrees down to 1.5, those risks, those frequencies will be a lot less. And it's amazing how significant the change will be for just that 0.5 degree Celsius difference. So it was all encompassing. It covered every sector. Everyone's got to contribute. Every sector's got to contribute. So this is kind of bringing us closer down from that. Reduce our emissions by 80%, reduce our emissions by 100% on a net basis, and limit that warming to no more than 1.5 degrees Celsius above those pre-industrial levels. Coming back to that map of the world that you saw earlier, keeping it down as low as possible. That report back in 2018 was very positive, saying that we've got the technology, we can do this, but we just need to go at pace and at scale. So it's a big challenge, but we have the ability. It's been done before in some circumstances, but maybe not both scale and scope and speed at the same time. And just one interesting fact out of that came out was that for 1.5 degrees Celsius, the globe is going to have to look at getting its electricity, at least 3/4 of its electricity from renewable sources. The UK has said that by 2035, all of our grid will be decarbonised. So 100% renewable sources by the year 2035. So we're motoring on that. Clearly, we're in COP26, lots going on, lots of great targets coming out. One of the interesting ones at the moment, which is also part of net zero, is a reduction in methane emissions, a 30% reduction in methane emissions by the year 2030. Methane is this almost forgotten gas. Everyone focuses on CO2 from combustion and energy use, but methane is 25 times more potent kilo for kilo than CO2 on a 100-year timescale basis, but it's almost kind of the poor cousin of greenhouse gases. It's very potent, it's very relevant to oil and gas extraction and other feedback loops that I've talked about in other sessions. So all eyes on COP for what we can do above and beyond just carbon dioxide as well. Excuse me. So thinking about the science-based route, some of you will have seen this graph before, and this is the explanation or one of the ways into getting your head around what net zero actually means. So I was talking earlier about how the UK's Climate Change Act was focused on 80%, but it's now looking at 100%, and I'll come onto that slide in a second. Here with this picture, what we're seeing is the increase in global greenhouse gas emissions. That's the black line on the left-hand side of the graph, slowly going up, and it's currently at about 50 billion tons of greenhouse gases. So that includes carbon dioxide, methane, nitrous oxide, all those other greenhouse gases. And it's slowly ticking up as everyone moves more and more on the planet to a more of a middle income, becoming middle class, or however you want to put it, having more affluent. Everyone wants more stuff, consume more stuff, so the greenhouse gases are going up, but we need to bend that curve down. And what this graph is talking about is the different climate scenarios in terms of temperature rises, depending on how much we continue to emit. So if we do nothing, we'll get 4 or 5 degrees emission rises, which is crazy. But we need to bend that curve down. Even the orange one, which talks about current policies, where there's a potential increase in temperature between 2.7 and 3.1 degrees Celsius. We haven't seen those temperatures globally for 3 million years. It was last seen on this planet in one of the dinosaur ages, way back 3 million years ago, when we had a temperature difference of 3 degrees more than where we are now. But obviously we want to bring it down to the 1.5 degree pathway I was talking about, and this is what Paris was focusing on, keeping it well below 2, or ideally 1.5 degrees as a maximum warming, which is why we have this 2 degree pathway and the 1.5 degree pathway. And the net zero concept is this little gap here in between the 1.5 degree pathway and zero, because we recognize that we're not going to be able to remove all greenhouse gas emissions. There will be some sectors, some processes, some industries that will still inherently emit some greenhouse gases. However efficient they are and whatever technologies and innovations they bring in, there will somewhere be some greenhouse gas emissions. So aviation is one where they're doing lots to reduce emissions, but there might still be some. Agriculture, definitely, because of the biological processes that happen in agriculture, and some industrial processes as well, where they inherently release carbon emissions. But the whole point of net zero is that we compensate for those. We take out an equivalent amount of carbon dioxide somewhere else, or directly at the power plant or at the factory where it's happening. They are removed directly, something known as carbon capture and storage. So the net zero concept is, how do we balance off that little bit that's still there with removals elsewhere? So I mentioned the UK's Climate Change Act. In 2019, excuse me, in 2019 it was updated. So if you recall, in 2008 it was an 80% reduction. We realized that that wasn't enough, and just before Theresa May left office in April 2019, this act was updated to 100% reduction, and this was on the advice of the Committee for Climate Change. That's the organisation who produced the graph on the right. We need to go to net zero as the UK, so our territorial emissions need to be, on balance, zero for greenhouse gases. So again, it's that same mantra of, we're still going to be emitting some greenhouse gases, but are we compensating for that amount elsewhere? Are we removing it from the atmosphere? And that's essentially what this graph is talking about. How do we reduce our emissions down to net zero by the year 2050, with lots of great ways of tackling emissions in transport, agriculture, manufacturing, aviation, shipping, housing, you name it. Each sector has to have its own routes to do that, but acknowledging that there will still be some hard to decarbonise emissions. Various different targets in Scotland and Wales. The Republic of Ireland has got its own target as well. And then back in March earlier this year, the UK government announced a intermediate milestone piece of legislation, which is a 78% reduction by 2035 versus the 1990 baseline. You'll very quickly get into this mantra of saying percentage by this date against the 1990 baseline. And you can see that that's on that purple trajectory that's already there. So it wasn't a new target, it was just making it legislative and saying, look, we want to make sure that we follow this as a country rather than waiting till 2050. And there's lots of other targets out there. You might have heard of Fit for 55, which is the European Union's version. So that's a 55% reduction by the year 2030. Mentioning a minute ago, our NDC is 68% by 2030. So you can see that that's on that same trajectory, 68% by 2030, 78 by 2035. So it's tracking our way down as much as possible, and providing the finance and the support and the innovation to make that happen. And it's good to hear actually from COP this week. There's lots of talk about financing the green transition and a just and fair transition as well, so that everyone's included. It's not just the richer developed nations that can go for this. There's putting more substance behind the words of saying, oh yeah, we'll support those developing nations. It's actually moving on from what's happened or what's not happened over the last 14 years and providing that money that they can transition to net zero as well. Okay, so a bit more into the detail. Like I say, net zero is about reducing your greenhouse gas emissions as much as possible, following the carbon hierarchy and in line with the Paris Climate Change Agreement. So looking at how we bend that curve down, that one I showed you earlier with the lovely pastel shades in pink and orange and blue and green, how we bend that curve down so we can reduce our emissions as much as possible. That's the science behind science-based targets. So we are, as individuals, as organizations and businesses, following that same kind of roadmap and trajectory down. The net zero bit is the gap that's left over, that's still there when it comes to 2050, and what are we going to do with those? Importantly, it needs to cover your whole value chain. This is not just about your organization. It's everything you do. It's the transport, it's the products and services you buy, it's the waste that you might create. It is an holistic approach. If we just focus on what we do, we're probably missing some of the biggest issues out there. There's many organizations where, particularly in the construction sector, where you'll find that the impact from your own organization is relatively small compared to the whole footprint when you include your supply chain and your customers as well. I think I gave the example on one of the other lunch and learns of housing developers, where the housing developer themselves, their own footprint, their scopes 1 and 2, might only account for 1 or 2% of their overall footprint. Their supply chain is roughly 2/3, and their customers, the house owners, is roughly the other third. So if you're going to be net zero, including those 2 bits of your scope 3 is crucial. Yeah, and that's to that point. The important thing is that with the hierarchy, that you can, the carbon reduction hierarchy, that you should do all your actions first of all to reduce energy, mitigate energy consumption, switch to lower forms of carbon where possible, and then only when you've done all those, then look at the greenhouse gas removals and compensation. Okay, there are several definitions of net zero. It is a bit of a VHS Betamax thing at the moment. It is coming in closer in terms of consolidating to standard definitions. One that's relevant to us is from the UK Green Building Council, that they describe net zero for construction in the way that it's described on the screen, about up to the point of commission and handover, that you reduce your emissions as much as possible, so they're zero or negative, through the use of offsets where needed. And there's a similar definition for operational energy. Reducing as much as possible, being efficient with the machinery and the equipment and the plan that you use, using renewable sources of energy where possible, and then only then, when you've gone through all of that, thinking about offsetting any remaining emissions that you might have to make that balance, that net zero balance. So there's a couple of phrases out there. Again, there's a bit of a wild west in some respects in terms of the phrases. Net zero and carbon neutral might sound synonymous, and they are similar, but they are different in some respects. They're both about a zero-sum balance between the greenhouse gases emitted and the same amount being taken out or removed or offset or balanced or compensated, but they have different boundaries. And if you're on my lunch and learn a couple of days ago on scope busting, you'll know all about consolidation approaches and organizational boundaries and operational boundaries and all that kind of stuff. This is really important. Carbon neutrality usually only focuses on scopes 1 and 2, so your direct emissions and your electricity, and maybe a little bit of your scope 3, like your business travel, but that's optional, although it is encouraged, and it does allow offsetting. Carbon neutrality is covered in the standard PAS 2060, so it's the BSI standard, and you can get yourselves accredited to be carbon neutral. So just take care, buyer beware, that when an organization says that they're carbon neutral or net zero, just kind of dig in a little bit. What do they mean about that? What is the issue behind it? What have they considered? What have they included in their boundaries? They're not always the same, similar but different. So some potential issues, as I say, so to be truly net zero, you need to consider everything you do in your supply chain and in your value chain. So upstream and downstream, everything that you buy, that you sell, transport, services that you use as well. And as I was indicating earlier, a huge amount of your impact could be in your supply chain, or ideally, indeed, it could be in your customers when you commission on, sell on product, service, you commission an asset, that kind of thing. So yeah, definitely follow the Paris Climate Change Agreement on reducing your emissions. So this is where science-based targets comes in. And yesterday, when I was talking about Science-Based Targets Initiative, there's a lot of explanation in there about how you commit and how you submit, commit to being science-based targets, and how you then submit for validation in terms of getting your target approved. So yeah, as I say, just to reiterate that, do be careful when you engage with other organizations, whether it's a customer or a supplier, what they mean by carbon neutral, carbon net zero. Just to reiterate, net zero is pretty much taken to mean everything. You're across your value chain and looking at your suppliers and your clients and everything, whereas carbon neutrality focuses on your own organization. There's nothing wrong with that, but there's a bigger world out there, essentially, is the short way of saying that. Yeah, and again, just to reiterate, offsetting has a role to play in terms of removing and balancing those emissions, but only once you've done everything else that you possibly can. So how do we reduce carbon? A quick bit of information on how the UK's grid has been decarbonised over the last 30 odd years. This graph shows you the carbon intensity of the UK's electricity grid, and it's been shown to have significant progress on decarbonising emissions over the last 30 years. It's reduced by about 2/3, essentially. It was at about 900 grams of CO2 per kilowatt hour per unit of energy produced. So that was from burning coal, gas, a little bit of nuclear, some renewables, but not very much. So quite high, almost a kilo per kilowatt hour. But it's come down by a long way in the last few years. So there's two big issues. There was a dash for gas back in the 90s, where we moved away from coal in a big way into combined gas turbines, and then more recently a big investment in renewables. So this is helping us track down to net zero, because we're moving more and more into renewables, particularly offshore renewables. We are an island, we're surrounded by sea and wind. We can make good use of that. And indeed, many of the big power companies are looking at offshore wind, as well as other things like PV, biomass, solar power, and so on. So lots of good work being done. And this is part, or one of the big contributions to that earlier graph I showed you, where we as a country are tracking down that solid black line in one of the previous graphs, where we've come down from something like 900 million tons of carbon per year down to about 500. So we're working our way down. Oh, so reducing power decarbonisation. Yes, so this is where it's going to go in the future. So again, this is what's being done for us. Reducing the carbon intensity of electricity. It's currently at about 220 grams of CO2 per unit, but you can see with the graph on the right that that's going to track down dramatically over the next few years as we move more and more away from coal and gas as well to more renewables. There will be some nuclear in that as kind of backup or kind of baseload provision, but the emissions are going to come down significantly if we're going to hit our targets. And this is where the mix of options comes into play. You can see on the right hand side you've got different fuels. So the kind of the pinkish color in the big block is all the variable renewables that will go into that. So a lot of offshore wind and PV and so on. There's a bit of hydrogen in there. And then there's other things there from nuclear and a few other sources as well. So you can see that there'll be big changes over the years to come in terms of how we get our power directly from electricity. So this rather complicated tangled graph from the Committee for Climate Change, looks a bit like multicolored spaghetti, is showing the different decarbonisation pathways for different sectors. And you can pick out this transport, shipping, manufacturing, electricity supply, aviation, and so on. And you can see that they all have their own different rates and different ways of getting down there, and how quickly they're going to do that as well, without picking on any particular one. But they're all going to have their own different strategies and different tactics to reach net zero by the year 2050. but some of them are harder to decarbonise than others, and I was mentioning this earlier, just because of what they do and how they get their energy and what emissions might come from what they actively do. So in particular, you can see in the graph as well, but just to highlight, agriculture, aviation, the waste sector, and the use of F-gases are some that are going to find it harder to decarbonise, and some manufacturing sectors as well. So you can see the aviation sector is this kind of mauve purple line up here, and the agriculture is this green line. I'm glad they coloured it green, so that would make sense. The agriculture is this green line. You see they're not down to zero by the year 2050. So this was the gap I was pointing at earlier. So when we talk about net zero, we're saying we've brought our emissions down as a country as much as possible, but there's still some emissions by 2050 from those sectors, and it's those that we need to compensate for, remove, offset at that time, but also in the run up to that. I've mentioned the carbon hierarchy a couple of times, carbon and energy hierarchy. It's very much like the waste hierarchy of reduce, reuse, recycle that we all know and love when we do put our recycling bins out every Wednesday or every Thursday, whatever night of the week it is. Unsurprisingly, it's quite similar when you come to carbon and energy. If you can avoid making the waste in the first place, if you can avoid using the energy in the first place, then don't do it. That's not always possible, of course. Quite often you do need to consume some kind of energy. When you do have to use that energy, be clever about it, be more efficient, be smarter, have more efficient equipment. Importantly, people's behaviours to make sure that they are using that equipment properly or using those materials properly, so we're not wasting materials or wasting energy. Where possible, switch to lower forms of carbon or renewables, so carbon zero entirely. Different materials have got a lower carbon footprint, embodied carbon. So all these different things, and there's lots of different ways of doing that. And as I keep saying, and I know I'm repeating myself, only when you've gone through all of those things, think about compensation or removal of greenhouse gas emissions. It's really important to follow that process rather than just jumping straight to some kind of offset and saying we're going to kind of pay our way out of guilt in effect. So reduce your emissions as much as possible. And there's benefit to doing that as well. There's financial benefits, there's efficiency benefits. You know, if you do lean, if you do Kaizen, if you do offsite manufacturing, all of these things play into this kind of way of thinking. And as part of that, it's good to develop a carbon reduction strategy to know where those hotspots are for reduction. So you can see the screen here that takes you through what that carbon reduction strategy would be, developing that scope, you know, what you're going to include. So this comes back to the carbon neutral versus net zero piece. It's not just your organization. You know, look at your supply chain, look at your customers as well. Agree what those boundaries should be and what your baseline year is to compare against. Go and grab some data, go and get some measurements. Understand who has that data and who you need to be friends with to get the information. Once you've identified that footprint and you've got your hotspots, go out and put reduction plans in place. Follow the hierarchy. Where can we avoid energy? Where can we use less energy? How can we switch our energy forms? Can we use different materials? Go and put those actions in place, and then come back at a suitable time and measure it again and work out, well, what have we actually done to bring those emissions down? How far has that come? What else do we need to do? Then you can think about offsetting or removal, putting measures in place to deal with that hard to decarbonize energy use or greenhouse gas emissions, and ideally reporting as well. Now, whether that's obligatory, legislative, or whether it's optional to your stakeholders and shareholders, in some way mark it and ensure that it is communicated to other people. Okay, so some of those carbon reductions actions, just very briefly, there's lots of opportunities to reduce carbon. I've just seen a question pop in that's saying, will a copy of this presentation be available? Yes, definitely. The PDF will be available afterwards. So just a few examples here of what can be done to reduce your energy, whether it's the equipment, the vehicles, the materials, recycled content, circular economy, all these good things come into play. There's no one magic silver bullet for solving this, which is a good thing. It gives us the opportunity to go and try different things that are suitable to us, relevant to our organization, the processes that we're dealing with. So yeah, it's lots of different things. And as I said before, really make sure that you improve the behaviors as well. having the right management systems, the right training, so that when you have pieces of equipment that might have a low energy mode or a standby mode or different ways of working, it's really useful to get people to know how to use them properly so that they can get the most benefit out of them. So a couple of case studies that talk about reducing energy and carbon emissions. There's one here on housing, about low energy housing, normal dwellings basically. They use off-site modern methods of construction. They're put up very quickly. They are using renewable materials. They're really eco-efficient. In effect, that they just don't have to heat their houses. So they are putting in measures in place to reduce their energy consumption as much as possible to get to a point where they're hardly having to use any. 10 times less than a conventional house. And any excess energy that's created from their solar PV, they're using to put into a grid. So when you get the slides, you can go and read that article should you wish. A similar one for a commercial development that's going on in London, and very much taking carbon as the lens to look at how to do it effectively, how to build it more efficiently and more cheaply as well. Thinking about net zero overall, and taking that kind of mindset to build in a process where you can say, we're going to get on and off site a lot more quickly, the installation time will be less, the cost will be less. So I think it says 33% less cost, 20% carbon reduction as well. So again, thinking of carbon in that design process, in that installation process, and how we can use this as a way towards net zero, how each of these designs and packages can contribute to that net zero journey. Okay. So importantly, what do we do with that residual carbon? So just to recap briefly, we've gone through the carbon hierarchy. We've looked at what we can do differently. We can put in triple glazing rather than single glazing. We can use renewable energy such as solar panels on the roof. We can use rainwater harvesting, which will reduce the draw for potable water if we're going to use it for irrigation or flushing toilets, that kind of thing. Lots of different things we can do, train our staff on how to use the facilities and assets. So we're working our way through that carbon and energy hierarchy as part of our net zero reduction plan, where we're thinking about where our hotspots are. We've calculated that, we've got a baseline, we know how much we're emitting, we're going to go after those hotspots. What can we do? Solar panels, triple glazing, electric vehicles, all kinds of different things. But we've done all that, and we've come back a year later or 18 months later, and we've measured it again, and we've gone, well, there's still some carbon emissions there. We still have that rump of hard to decarbonize emissions. What do we do with them? This is what this section is about. So what does carbon offsetting mean? It's about compensating for the greenhouse gas emissions that arise from an organization or a product or a project in one place, and you kind of balance them with emissions from somewhere else by removing them or avoiding them somewhere else. And not all offsetting is the same. There's different kinds of ways of offsetting. It's a bit of a kind of an umbrella term. So it could be avoiding emissions somewhere else, or reducing emissions that were happening anyway, or just stopping activities altogether. So it's about that balance, and that graphic on the right hand side tries to give something towards that. So the way you do it as an investor is that you'd pay some money into projects that are looking for investment that will lead to lower carbon emissions somewhere else. And the important issue is here that without your investment and the investment of other organizations, those projects wouldn't have happened. And this is something called additionality, which I'll come on to in a minute. But essentially, if this was going to happen anyway, if this avoidance or reduction project was going to happen anyway, your money is not going to be the deal breaker for that. So this is why it has to be a case to count as carbon offsetting. It has to be something that's additional and wouldn't have happened without your investment. Sometimes it's called compensation. There are lots of different words going around. So kind of be aware that offsetting, compensation, neutralization is another word that's used sometimes in this setting. So yeah, be aware that it's not always called the same thing. So the benefits of carbon offsetting is it's along the lines of the polluter pays principle. So it gives a level of responsibility for the emitter by putting a price on carbon. Undeniably, offsetting has had a lot of stick in the press. It is very susceptible to greenwashing, and something I'll come on to later is how you avoid that kind of that accusation of greenwashing. There are some very good, robust offsetting schemes, and there are others which are a bit more flaky. There is a lot of ability to meddle with this. So again, it's kind of go in with your eyes open, buyer beware. But what it does is it helps invest in those low carbon schemes by reducing reliance on fossil fuels and supporting them that otherwise wouldn't have happened without your investment. But it also brings other benefits, not just directly carbon and climate change. We can look at biodiversity gains, we can look at social improvement, increasing wages and job opportunities for people, and their health and well-being as well. There's lots of data out there that says that some of these schemes are really supporting people's health and well-being, as well as reforesting or reducing carbon emissions. So it's not always just about carbon. So if you're looking into offsetting schemes as part of your carbon reduction strategy, think about some of those other social benefits as well that might be relevant. And as I say, it's that final piece in your carbon reduction strategy. So you've gone up that staircase to of identifying your footprint, where are the hotspots, taking those reduction actions, or putting a plan in place to take those reduction actions, and then looking at what you've got left over before you do this. Okay, I've just seen a question about how much this will cost. I'll come on to that in a minute. What does good offsetting look like? And this is the point I was making earlier about understanding what is good and how to avoid that kind of greenwashing accusation. So there's several things that you need to have or you need to see in an offsetting scheme for it to be trustworthy. It needs to be real, it needs to be verifiable and traceable. Now that might sound obvious, but there have been many offsetting schemes where they just don't physically exist. Simple as that, it's a scam. It's like anything else in life. If you go online, there are other scams out there. So it has to be real. There has to be actually a program or a project happening somewhere, whether that's planting trees or cook stoves or some kind of irrigation project, whatever it is, it has to be real. Seems like stating the obvious, but there you go. It has to be additional. So this is the point I was making earlier. It has to be above and beyond what would have happened otherwise if your money hadn't been there. If it was going to go ahead anyway because it was getting government funding, then it's going to happen anyway. So what you're doing is not additional and above and beyond. What we're talking about here is that offsetting and the payment for offsetting is making these projects happen. And we're getting, as a planet, we're getting additional benefits that we would have otherwise not got had you not paid in that money. There's a lot of subjunctive clauses in here. If you had done this, had something else happened. So it has to be additional. It has to be measurable. We have to be able to say, doing this scheme or funding this scheme will lead to so many tons of carbon dioxide being avoided or removed or reduced. It has to be measurable because you pay per ton effectively. So it has to have a mechanism, a robust mechanism behind it that says this is how much will be removed, and therefore you can put a financial value on that, dollars per ton, pounds per ton. And it has to be permanent. Again, this might be stating the obvious, but there have been examples where people have sold offsets for trees, for forests, and then someone comes back a few years later and that woodland is no longer there. It's been chopped down and sold for timber. Again, a scam. So making sure that it's permanent and using the right offsetting scheme, the provider who can link you up with a quality, trustworthy, robust scheme is paramount in this. So it's got to be good quality offsetting. And permanence is one of those things as well, that it stays there, particularly when we're talking about tree planting as well, because it's all too easy. The itch is all too easy to scratch, to chop it down and sell it for timber. So make sure that what you're getting into is permanent as well. And the mnemonic I've made up for that is RAMP. Helps me to remember things with a mnemonic. So if you're going out and getting offsetting, think of RAMP, ramping up your carbon emissions, your carbon expectations, sorry, not your emissions, that's entirely the wrong way around. But it's got to be backed by the mechanism that's independent, is transparent, it's inclusive. So all the kind of the governance that goes behind it has to be transparent and robust as well. Particularly, we want to avoid double counting, that we don't sell those offsets more than once, and that they get retired once they've been purchased, that they don't get then sold on again, because then we can lead to double counting. So there's got to be that robust governance that goes with it. Okay, so examples of some carbon offsetting projects, and they cover the whole carbon hierarchy. So if you think about avoid, reduce, switch, those first three bits of that pyramid that I showed you, So avoiding and switching, so you can use renewable energy. So if you're funding, for example, solar panels or wind turbines somewhere that are producing renewable energy, you're switching from a fossil fuel to a non-fossil fuel to a renewable source, and there'll be a reduction in the carbon emissions associated with that. Had you not funded that, they would be using oil or gas or kerosene instead and creating carbon emissions. But with the solar panels or the turbines, they're creating their electricity with zero emissions at the point of use. I'm not going to get into the embodied carbon discussion on that just now. That's for another webinar. Another example is reducing your emissions. So methane capture is one of those. Wastewater treatment works and other anaerobic degradation processes cause methane emissions. And as I've said, methane is 25 times worse than CO2, kilo for kilo. But if you can capture that methane and use it in a turbine, in an engine, and create electricity from that, you're still going to be emitting CO2, but it's 25 times less bad than emitting the methane, and you're getting electricity out of it as well. So you're getting a double win for that. So you're reducing the overall greenhouse gas emissions as well. There's also things like the cook stoves. You can see in the bottom left-hand corner, that's a very, very popular one where people are provided with a more efficient cooking appliance, and it burns more cleanly, it burns hotter, it's a lot more efficient basically. So overall, on average, the CO2 emissions are far, far less from one of these cook stoves rather than just an open fire with wood or coal. It also brings health benefits as well because it burns more cleanly. There's less air pollution as well. So the people who use it get a well-being health benefit as well as the reduced carbon emissions. And then the one that we probably all know about is planting trees, whether that's reforestation, so that's a forest that's been denuded and is being planted back up to where it was, or afforestation, which is taking land which hasn't been forested for a long, long time and putting trees back for the first time in a long, long time. So that's the one that most people go to. And then finally, carbon capture and storage, CCS. So this is about literally capturing the CO2, the carbon dioxide, out of the atmosphere and storing it somewhere. You sometimes might see that written as CCUS, carbon capture use and storage, because it might be used somewhere else before it gets stored or in some other application. But essentially it's capturing that carbon from source. And then you can see many other examples there, efficient equipment where you get reduced emissions compared to a market average had you not invested in it. So the practicalities of offsetting. What we're saying here is that on this graph, and it's fictitious here, that your business as usual emissions in the blue line are kind of going up over time. You can see time is on the horizontal, and on the vertical you've got emissions in tons of carbon, and they're steadily going up as you run the business. But you might look at purchasing an emissions offset project or purchasing credits from that, and that's where you get that reduction, you get that difference. So you want to compare the two, and you measure your reduction in the emissions, and that's essentially what that yellow shape is there. So the cumulative emissions are the same as the area of that yellow shape. So it's obviously year on year, you're reducing it by, on this graph, 2 tons, but over time you can add up 2 tons, 3 tons, add them up as you go along and get your total emissions reduction from the offsetting that you're doing. Because as I say, it's got to be permanent as well. It's not just going to be for one-off. And then in terms of some of the jargon, some of the wording, 1 ton of carbon dioxide equivalent avoided or reduced equals 1 carbon credit or 1 offset. So it makes it simple. When you buy offsets, you buy per ton essentially of carbon dioxide, and that's why you need the measurement piece of RAMP. Not only has it got to be real and existing, like I was saying, it's got to be measurable so that you can then pay for offsets. You can then say, look, I've got 300 tons of carbon dioxide equivalent that are hard to decarbonize in my organization. I need to buy 300 credits, 300 offsets. And to do that, someone needs to go off and have a measurable scheme or project against which to sell you those credits. So how much does it cost? I think this was one of the questions. Some typical offsets are given on the screen here. They're in US dollars. So take about 2/3 of that number to get the pound sterling price. Sadly, they're always sold in US dollars, so you'll have to do that conversion if you go and buy. But yeah, you can see that $10 a ton for renewables like wind and solar, a bit more for cook stoves, and a bit more again for reforestation. It really does depend. And when you go on the websites and looking for them on the robust, good quality offsetting websites, that you'll see there's a whole plethora of different choices, and they speak to different people's different desires. Some are things very high tech, like the renewables of wind and solar. Some are more social, like the cook stoves or providing clean water. Others are more about biodiversity, and again, it's not just about boshing trees into the ground, it's about creating more biodiverse habitats, and creating the jobs that go around those as well, people who are going to look after those places, who are going to attract the tourism in, if relevant, as well. An interesting aside on this, there's been increasing interest in what's known as blue offsets. So blue offsets are where you invest in the ocean or in waterways where there's offsetting schemes going on that are aquatic in nature. They're not on land, they're not terrestrial, so that's why they're called blue offsets. And some amazing facts that come out of that is that with a blue carbon offset, so you're investing in mangrove swamps, or putting plants back in river deltas or whatever it might be, that the rates of carbon absorption are far higher than trees. It's something like 10 times more carbon is absorbed by those aquatic systems than the terrestrial systems. So they're getting a lot of traction, a lot of interest from businesses in terms of going at a quicker pace than necessarily with terrestrial offsets. So do have a look into that. As a slight aside on that, those are called blue carbon offsets, which is a good thing, and they are really good. A lot of these things these days seem to have a colour appended to them, so you get blue carbon offsets. You can also get green hydrogen, which is a great production of hydrogen as part of your carbon reduction strategy. So producing hydrogen gas through using renewable energy to electrolyze water and create hydrogen. Sadly, there's a thing called blue hydrogen, which isn't so good because that comes from natural gas, so it's still a fossil fuel based hydrogen. So blue hydrogen isn't quite as good as blue carbon offset. So just be careful when you see colors and don't mix them up, that they all necessarily mean that they're good or bad or the same. Okay. In terms of the actual offsets, there's two main routes to getting offsets. There's something that the UNFCCC runs and manages, the Clean Development Mechanism. So the UNFCCC is the United Nations Framework Convention for Climate Change. They're the people who are basically running COP26 at the moment. And they have a system for providing offsets. It's global. It's backed by governments who are party to the Kyoto Protocol and the Paris Climate Change Agreement. It's all public because it's a public organization, a global NGO body, public registry of all the projects and all the credits, so you can go and search it. They keep the project validation separate to the verification. It's like a poacher gamekeeper thing, so they keep it separate. And there's some other details about how long those offsets are valid for. Importantly, they are limited to developing nations to drive sustainable development. It's very much part of their ethos that developed nations can and should be doing it themselves, but developing nations need more support. This is one of the mechanisms. And here the offsets are called certified emissions reductions, CERs. Again, it's a bit of jargon, a bit of lingo, but understanding that they call them slightly different things, albeit they're largely the same thing overall. So in this case, it's CERs, certified emission reductions. And again, you pay for one credit, one offset, you pay so many dollars, so many pounds, and you get a ton abated somewhere else. There are kind of lots and lots of voluntary carbon market mechanisms, loads of them out there, and some are international, some are regional, some are country-based. There's a huge array to choose from, many of them run by private organizations. Many of those are NGOs in and of themselves, but not all of them are equal. And this was the point I was stressing earlier with the greenwashing risk here. So this is why you need to check for RAMP. Is it real? Is it additional, measurable, and is it permanent? So the three I've put here are probably the three most well known in terms of being robust, good quality, high quality offsetting schemes. The gold standard, the VCS, verified carbon standard, and Plan Vivo as well. They have schemes all over the world. They don't just have to be in developing nations, they can be in developed countries as well. There's slight difference of approach on governance in terms of disclosure, in terms of verification and validation of projects. So slightly different criteria as well in terms of how long that they are valid for. But essentially they're driving at the same thing. And these ones are shown to be good quality. These ones are in the marketplace and people turn to these three in the main. There are others, and there's a whole long list of them. And if you have something that's particular for your region or your country, you can go to some of the other robust ones as well. But their reach is generally smaller. You know, they might only focus on biodiversity and forestry. They might only focus on a particular country. These ones are generally a lot wider reaching than some of those others. Here, the offsets are called verified emission reductions or voluntary carbon units. It's lots of three-letter acronyms, but essentially it's about, you know, paying for a ton of offsets. So when you go to look for these, I'd go to these one of these three or the one I just showed you, and look for those and check out what they do. But again, going with your eyes open if you're looking at other offsetting schemes. But that's just offsetting. That's about reducing the emissions. So the cook stoves is a good example, or some of the others where you say there still are emissions, but there's just less than there would have been had we not invested. So we're still emitting some carbon, but we're just emitting a bit less than we would have done otherwise. So that's that kind of a bit of compensation, a bit of avoidance, that kind of thing. What we're looking at going further, taking a step further, and this is where we transition from offsetting to proper net zero and removal, is how do we actually remove greenhouse gases from the atmosphere, literally take them out of the atmosphere to stop them causing problems. I've taken a screen grab from the greenhouse gas removal report by the Royal Society. Does what it says on the tin. It gives a lot of really good information about going further than just compensating or balancing off emissions. Because if we think about it in offsetting, you're still emitting your hard to decarbonize emissions, and what you're doing is balancing them off somewhere else and saying we're going to invest some money, and that other organization will then reduce their emissions above what they would have done otherwise, and that balances what we're doing. But we're still emitting our emissions. They're still coming out, and the organization we've invested in is still emitting as well, albeit less. So yes, that's good, and that's a good stepping stone to take, but over time we should be transitioning to greenhouse gas removal. So it goes further, it actively takes them out of the atmosphere. And there's lots of different routes. Again, there's no one single solution, lots of different routes to sequester carbon, which is, for those of you who don't know, sequester just means extract or pull out the carbon from the atmosphere. And there are different stages of development, but it's what's needed for true deep decarbonisation. If you read all the reports from the IPCC or the Committee for Climate Change, they use this phrase of deep decarbonisation. So really going after removing our carbon emissions rather than just balancing or avoiding what we've got there already. So I'm going to give you some of the examples, and you will see some overlaps with offsetting as well, particularly afforestation and reforestation. This is where there's an overlap. You can already buy offsets for reforestation schemes, but this is where we are truly removing carbon dioxide from the atmosphere. As we all know, when plants grow, whether they're on land or in the sea, they absorb carbon dioxide in their growth and they turn that into biomass. And that's really key. Just to give you a bit of a pub quiz fact, a tree in its average life, if a tree is allowed to live to 100 years, it will absorb about a ton of carbon dioxide. So if you think about the huge mega billion tons of carbon I was talking about earlier, and you convert that into numbers of trees that have to be there, we're going to need to plant a lot of trees. So yeah, 1 ton of carbon over its 100-year lifetime. But yeah, we can do that. But again, it's that ramp thing, making sure that that forest stays there and it has additional biodiversity benefits as well, because there's a biodiversity crisis as well. And making sure it's measurable and it's a good quality offset when we do that. But similarly, that it's actually removing carbon. Similarly, wetlands, peatlands, coastal habitat restoration. The example I was talking about earlier was focusing on mangroves in the Caribbean off the coast of Colombia, and about creating great areas for removing carbon, particularly in the sediment, not so much just the seagrasses and the mangroves that grow, but particularly in the sediment, that once it's there, it pretty much stays there. There's less risk of it being chopped down or being taken away, but also the biodiversity benefits that that habitat brings to that area. And then there's various techniques in agriculture as well about sequestering carbon dioxide into soil, kind of no plough options and different ways of farming that will increase the carbon content of the soil that we have rather than releasing it out, particularly methane as well. Building with biomass, that seems probably one of the most obvious as well, using timber to create buildings. It's happening more frequently. I showed you a couple of examples earlier where they're looking at using more timber products in buildings. that can certainly be done, but again, it's got to be permanent, because if that timber is removed from the building even 50 years from now and it's burnt or it's put in landfill, that sequestered carbon is released back into the atmosphere. There's no net gain from it. So it's about locking it away permanently. So building with biomass, buildings, furniture, that kind of thing. There's a slightly more technical approach in agriculture called biochar, which is essentially, in simple terms, it's like charcoal, taking naturally grown timber, processing it or pyrolyzing it, so that's burning it in the absence of oxygen, and it turns into effectively charcoal, and then that is ploughed back into the land. It adds nutrient to the land, so it's beneficial to agriculture, but it also takes a lot longer to biodegrade and release its carbon. So it's locking away that carbon on a more medium-term scale than would otherwise have happened. And then there's a few others where we do actual capture and storage in terms of locking it away more technically rather than using purely natural solutions. So again, you can take your biomass and you can combust it for energy production, and then you can capture that CO2 directly and do something with it. You can either lock it away in a geological reservoir, or you can mix it into other minerals where it something called mineral carbonation, where it actually reacts with the rocks and gets locked away as a carbonate in the rocks. And then the one that seems probably the most obvious or the most straightforward, but is actually technically very difficult, is direct air capture carbon storage, otherwise known as DACS. So this is extracting CO2 from the air, passing it through a solution till it's saturated. And when it is, you then heat it to drive off the CO2, but in concentrated format. And then that's reacted with various different basalt rocks. So again, it's mineral carbonation to lock away the CO2 in the geology of the planet. There's a few power stations or CO2 power stations doing this already in Iceland and other places. There's one there called Hellisheidi, where they're actively sucking the CO2 out of the air in effect and locking it away in the rock formations below the power station. So there's lots of different examples here, and this is not to say that you as an organization needs to go and do these yourselves, but these will be coming along more frequently in the coming years as options to invest in to remove carbon actively. So again, it's your carbon reduction strategy. What can you do at the end about removals? Investing in these kinds of things is the way forward. Some of these are really high values at the moment, but market forces will bring them down. So I think I saw one figure somewhere that it was something like $600 per ton of carbon dioxide for the DACS that you see in the bottom right hand corner. So clearly a lot more expensive than offsetting, but market forces and market dynamics will push that to a lower price, as with everything else that we experience. So just to reiterate your carbon reduction strategy, think about going through all those good things first in terms of your identification, understanding where your hotspots are, driving down on your actual direct energy use as you see it now, and then think about that investment piece, good quality offsets in the short term, and in the medium to long term, investing in GHG removals. And that's it for the moment. So thank you. For those of you who need to pop off for another meeting, we're probably all living that back-to-back lifestyle at the moment. So thank you for your attendance. I'm going to stay on and try and answer a few of the questions that we've got in the chat box, in the Q&A box. And just to say that the feedback form is in the other chat box that Sophie's posted there. If you are able to review that, then please do. That's really helpful for us. And then we'll share the slides and the recording in the next few days. So goodbye to those of you who need to dash off, and for the rest of you, I will carry on for a minute. So I'm just going to stop sharing and look at some of the questions. So, question from Jim: what systems are in place for allowing organizations to get verification of carbon neutral or net zero? So carbon neutral, there's a standard that I mentioned past 2060 where you can get an external third party to come in and check your numbers, and essentially you need to follow the guidance in that standard of producing a footprint, what's involved in your organization, where you emit, how much, and also your plan for reducing it, and they can come in and help certify that you've achieved that carbon neutrality standard. And part of that is we'll be purchasing offsets to balance what you've still got, like I was describing. Net zero, there's no one standard for it, although the science-based targets have in the last couple of days just come out with their version of what net zero should look like, and reducing it down. But the best way with net zero at the moment is to go for a science-based target. We should be clear here that science-based targets are different to a net zero. So science-based target is about bringing your emissions down as far as possible. Net zero is that last little bit. So if you remember my graph further up, you're bringing it down as much as possible, then there was the red line to bring you down to net zero. So they're kind of 2 steps in that process. So a question from Simon. Can't follow why it's necessary to look at the supply chain. Surely if they and we all look at our own situations and aim for carbon neutral, we're all advancing together. Yes, double counting, yeah. So ideally, if everybody was on this and everyone was on the same bus and looking at their own direct emissions, we wouldn't need to bother with the supply chain because everyone in our supply chain would be doing it as well. So we'd only need to focus on scope 1 and 2 emissions, our own direct emissions and our electricity. Sadly, that's not the case. We can't just rely on our own direct emissions. We need to look at our supply chain and what they're doing as well, because not everybody is working their way towards net zero. The double accounting piece is all about why we have scope 1, 2 and 3. So in very simple terms, my suppliers' scope 1 emissions from when they use an excavator on site and burn some red diesel, that's their scope 1 emission, but that's part of my scope 3 emission because it's in my supply chain. So it's not double counting. It is the actual same molecules of CO2 going into the atmosphere, but it's about who's responsible for it. So scope 1 for my plant hire contractor and scope 3 for me. From George, how offsetting projects declare their capacity to absorb emissions from others? If everyone uses the same offsetting project, that can only deliver up to a point, for example. Yes, basically, they will go through this governance process as a scheme to say, well, what carbon can we avoid? And they'll actually measure it. That's the M in the ramp bit. Can they measure how much CO2 that they will absorb or avoid if they plant 100 trees? And they need to have a measurement, a way of measuring that to say, right, okay, if we reckon these 100 trees will absorb 100 tons of CO2 in their lifetime, we can sell 100 tons of offsets and we'll put a price on that, but we can only sell 100 tons. That's where the greenwashing comes in, where someone tries to sell that 100 tons of carbon offset more than once, and then you will get double counting. So that's why you need to find really robust schemes where they avoid that temptation to sell the same thing more than once, and hence why you need that reliability, that robustness to your offsetting schemes. In terms of the cost itself, they will work out how much it costs them to invest themselves in that initiative and balance that against how many tons they are thinking that they're going to save or avoid, and then you can do the maths to get what it is per ton, what the price is per ton. So just a couple more. Is the offset for embodied carbon a single payment, and is the offset for operational carbon an annual payment? Very good question there. So if you're looking at building an asset, for example, embodied carbon is generally speaking a one-off. You've built the building or the asset, it's done. Don't forget, of course, that you've got maintenance through the lifetime. If you're looking at some of the different standards and protocols out there, it's not just the construction, it's the maintenance, the refurb that comes in that embodied carbon question as well, sometimes called capital carbon. So you need to think about that as well, where the fabric of the building might be updated and you're changing the light bulbs because the light bulb is broken, all that kind of maintenance piece as well. But essentially the biggest bulk is going to be in the construction. And you could say, well, we calculated that the construction was 10,000 tons of carbon, we'll buy an offset for that. Annual is ongoing, as you rightly say. So thinking about what those emissions are on an annual basis. Okay. 2 questions from Niall. Is there an accepted percentage of emissions that it's okay to offset? Or is there an unwritten rule that you should reduce X before you even consider? I have never seen anything that someone comes along and checks and says you need to have reduced your footprint by X% before you can even engage with us. That's not in the spirit of trying to tackle it, because you might have organizations that say, we've understood our footprint and we've got a great action plan for reducing it, but that's going to take us 3, 5, 10 years time in terms of the investment cycles, in terms of new technologies and so on. But we want to be responsible for our emissions today, so we want to offset them today. So that could be 100% offset, as long as it's robust and it's ramp and all that stuff, that they might want to do that. But over time, those offsets would get less as they go through that innovation and investment program. And then your second question, in terms of additionality, does this include activities we should be doing anyway? So planting trees that need planting anyway shouldn't be counted as offsetting. Yeah, so this is where we have to be clear about the additionality piece, that when you're investing, it's your investment that triggers that project to happen. If you're going to go off and with your own organization and plant trees, that you can sometimes think about that is called insetting. This is kind of the next stage on here about doing those offsets yourself within your own organization. Sometimes it's called insetting. But the key point I want to drive home here is that if you invested in a rainforest project in Central America somewhere and the government was already funding that project, it's going to happen anyway, which is a good thing. We shouldn't avoid that. That should be happening anyway. But your investment needs to trigger something that wouldn't have happened otherwise. Green hydrogen. Yeah, I'm happy to talk about that again. So you're probably aware that there's a transition away from fossil fuels. People have talked about electric vehicles, whether it's your own car or whether it's an excavator or whatever other vehicle. There's also an option to use hydrogen as a fuel, and hydrogen can either be used in a fuel cell, so it goes into a battery in effect, and it's used as the source to make electricity in a battery. That's called a hydrogen fuel cell, or it can just be burnt directly, like an internal combustion engine, but using hydrogen instead of diesel or petrol or LPG. Either way, you've got to get the hydrogen from somewhere, and the most abundant source is obviously the sea. Again, we're an island, we're surrounded by it, but you can also get it from a chemical process by splitting natural gas and other fossil fuels. You can put them through a chemical process, pass the gas over a catalyst, and it splits it into hydrogen and carbon dioxide and other molecules as well. You can capture the hydrogen and use that as a fuel, but you've created CO2, so it's still a fossil fuel creating CO2, so you're not actually gaining much benefit in terms of the climate crisis. You've made a transportable fuel in the form of hydrogen, but you've also still created CO2 as part of that, and that's called blue hydrogen. That's the kind of the shorthand parlance for it. So it's being touted as a stepping stone at the moment. Has its benefits in some respects, because if you burn hydrogen, there's no tailpipe CO2, there's no tailpipe air quality emissions that you would get with diesel or other fossil fuels. And importantly, if they capture the CO2 that's created from that chemical process I just outlined, then it's going some way to avoiding that climate impact from CO2 emissions. But yeah, it's a stepping stone. Better to go to green hydrogen, which is where you take seawater, or any water for that matter, and you electrolyze it. You put in 2 electrodes and you pass an electric current through it, and that splits the water, H2O, into hydrogen and oxygen. The oxygen you can just let out because that's fine, we kind of need oxygen, but the hydrogen you can capture and use as a fuel. And the trick with that is for the electricity that you use renewable energy, so it is green, it is renewable. So that's why it's often done with seawater on a coast, because you've got abundant seawater. You're generally fairly close to a wind turbine farm out in the North Sea somewhere, so you've got your energy supply as well, and you can create that hydrogen. There's been a few case study examples of delivering that into housing on the east coast of Scotland, I think in Fife, somewhere around there. 300 homes or 1,000 homes or so are being run in terms of their central heating using green hydrogen. So the technology is proven, it's about scaling it up so we can use it more effectively. Cool, I think we're done. If any of you are still there, I think 50 of you are still there. Thank you very much for listening. Hopefully you found that useful. We'll see you again sometime soon. Have a good weekend. Bye for now.